Now we want to see how we can add some flexibility into these loans so that, for example, we can put extra money in, take extra money out. First thing I want to do is just get this back to be the original 40,000. Okay, so we've now got back to our original calculation. And I'm going to go over here. So what I want to show you is how mathematically we can calculate what the repayment has to be without looking into the past. So just if you look at the way we've set this up, we've got our same opening balance, we've done the calculation of interest, we need to work out the repayment. And just notice up here we've got a header, but it goes backwards. It goes from 12 months, so what is he saying? There's 12 months to go on this loan. There's 11 months, 10 months, etc. What I want to do is show you how you can set it up so that you can calculate what the repayment amount should be based on what the life left. So the first part is we go and we find our PMT function. What's the rate? So we're going to use our interest rate here, divide by 12. How many periods in this loan? So normally we'd go and say 12 months, but what we're going to now say is look at this header, because each month is going to be less and less. What's the present value? Well, the present value when we're in month 11 is going to be a different outstanding balance. So I'm going to just refer to this cell here, no dollar signs. Future value, we know it needs to be minus whatever's in there, put the dollar signs on, and type's going to be a 0. When I say OK, it gives me 5731, which is the same as what we had up here. If I copy it across all the way, you'll see we get back to the 40,000. But what's interesting about this is, let's go, for example, here. This is actually a calculation of an 8th month loan on 80,000 Rand to get to 40,000 Rand. And you'll see it gives us the same amount. So if everything is exactly the same, these numbers should be exactly the same. So why is this useful? Well, what happens if over here we decide we need to take out another 50,000? So I'm going to put plus 50,000. You'll notice that this automatically changed the repayment amount so that we end up on the same number. And perhaps over here we pay back a lump sum of 30,000. Notice again the repayment changes, so we end up in the exact same position. Because it's going to be important to work out what's interest and what's capital, we can still use PPMT and IPMT. So I'm going to go over here, let's sit there. We're going to work out the principal payment. So most of it's the same. PPMT, what's the rate? Just come up here and say it's that, divide by 12. Let's just leave the period out. What's the number of periods? Now remember, we don't want to go and click on a static number. We're going to use our header up here. We're going to say there's 8 months left in this loan. What's the present value? We're going to use this number up here. What's the future value minus 40,000 with the dollar sign? And what's the type? It's a 0. So the important thing here then is, what is the period number? Now previously you would have looked up here and said it's period 5, but remember this is saying it's only an 8th month loan. So what period is this of an 8-month loan? Well, it's going to be period 1. If I copy it here, we're now going to have a 7-month loan. What period is that of a 7-month loan? It's also period 1. So we're actually going to hard code 1 in here. So when I say OK, you'll see it gives me the exact same number of the capital portion. When I copy it across, you'll see that it always matches up, even though we've got places where we suddenly put money in and take money out. Exact same logic with RPMT with regards to interest. So it's RPMT, what's the rate? 12% divided by 12. What's the period? We now know it must be a 1 because the number of periods is declining. Present value is opening balance, future values minus the 40,000 with dollar signs, type is 0. When I say OK, 1308, 1308. So I can copy these across like that, and you'll see it matches up.